ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಕ್ರೊಮಟೋಗ್ರಫಿ ಇದ್ರ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. Michael Tswett is a Russian scientist. In the year 1906, he explained the concept of chromatography technique. He employed chromatographic technique to separate the various plant pigments such as chlorophylls, xanthophylls, and several other colored substances by passing solution of these compounds through a glass column packed with finely divided calcium carbonate. The column of calcium carbonate was an adsorbent. The different compounds were absorbed at different extent. This leads to color bands at different position of the column. Michael Tswett called this system of color bands as chromatogram, and the method is known as chromatography. The calcium carbonate used by the Michael Tswett remains stationary, therefore it is called as a stationary phase. The solution moves down the column, it is known as mobile phase. ಇದು ಮೈಕಲ್ ಸ್ವೆಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. ಫಸ್ಟ್ is taking the glass tube. It is called glass tube. It is very similar to burette without any readings on the surface of the glass tube. The glass tube, it is very similar to burette without any readings on the surface of the glass tube. Then the glass tube is filled with calcium carbonate. The glass tube, it is filled with calcium carbonate. It will act as a stationary phase. ಇಲ್ಲಿ calcium carbonate ಮೂವ್ ಆಗೋದಿಲ್ಲ, ಅದನ್ನ it will act as a stationary phase. Then we are taking plant extract at the top of the column, means glass tube. ಇಲ್ಲಿ ತಗೊಂತೀವಿ plant extract contains many compounds. ಇದು ಸ್ಯಾಂಪಲ್, ಇದು it contains many compounds. ಅದನ್ನ ನಾವು ಇಂಡಿವಿಜುವಲ್ ಆಗಿ ಸಪರೇಟ್ ಮಾಡಬೇಕು. Then we will add petroleum ether. It will act as a solvent. This petroleum ether undergoes interaction with plant extract, then it move on the surface of the calcium carbonate. ಏನಾಗುತ್ತೆ, ಈ petroleum ether it undergoes interaction with plant extract, then it will move on the surface of the calcium carbonate. After some time ಏನಾಗುತ್ತೆ, different color bands appear ಆಗುತ್ತೆ on the surface of the calcium carbonate. different color bands ಅಂದ್ರೆ different compounds, different color ಅಂದ್ರೆ different compounds. This sample contains 3 compounds, that is di A, di B, di C. ಮೂರಿದೆ. that we will collect in the separate beaker. Simple ಆಗಿ ಹೇಳ್ತೀನಿ ನೋಡ್ರಿ. First we are taking glass tube. The glass tube, it is very similar to burette without any readings on the surface of the glass tube. Then the glass tube, it is filled with calcium carbonate. This calcium carbonate move ಆಗೋದಿಲ್ಲ, therefore it will act as a stationary phase. Then we are taking plant extract at the top. Then we place petroleum ether. It is a solvent. This petroleum ether undergoes interaction with plant extract, then it will move on the surface of the calcium carbonate. ಇಲ್ಲಿ ಯಾವ್ದು ಮೂವ್ ಆಗ್ತಿದೆ, petroleum ether and plant extract. Therefore this two ಏನದು mobile phase. petroleum ether plant extract move ಆಗುತ್ತೆ, therefore it will act as a mobile phase. Whereas calcium carbonate ಮೂವ್ ಆಗೋದಿಲ್ಲ, therefore it is a stationary phase. ಈ ಸ್ಯಾಂಪಲ್ ಎಷ್ಟು ಕಾಂಪೌಂಡ್ಸ್ ಇದೆ, 3 ಕಾಂಪೌಂಡ್ಸ್ ಇದೆ, ಬಿಕಾಸ್ ಕಲರ್ ಬ್ಯಾಂಡ್ಸ್ ಅಪೇರ್ ಆಗಿದೆ ಇಲ್ಲಿ ಕ್ಯಾಲ್ಸಿಯಂ ಕಾರ್ಬೊನೇಟ್ ಮೇಲೆ. therefore it contains 3 compounds that we will collect in the separate beaker. ಇದು ಮೈಕಲ್ ಸ್ವೆಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. ಹಂಗಂದ್ರೆ ವಾಟ್ ಇಸ್ ಮೀನಿಂಗ್ ಆಫ್ ಕ್ರೊಮಟೋಗ್ರಫಿ, ಯಾವ ಥರ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೋದು, ಡಿಫೈನ್ ಮಾಡ್ಬೋದು. Chromatography, it is a branch of analytical chemistry, deals with separation of a mixture into individual components. It is called chromatography. Chromatography is nothing but separation of a mixture into individual components is called chromatography. The name chromo, it is from the Greek word chromo means color, graphene means to write. Chromo ಅಂದ್ರೆ ಏನು, ಕಲರು, ಗ್ರಾಫಿನ್ ಮೀನ್ಸ್ ಟು ರೈಟ್. ಸಮಟೈಮ್ಸ್ ಗ್ರಾಮ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಗ್ರಾಮ್ ಅಂದರೆ ಬ್ಯಾಂಡ್ಸ್ ಅಂತ ನಾವು ಹೇಳ್ತೀವಿ. ಓಕೆ, ಕ್ರೋಮೋ ಮೀನ್ಸ್ ಕಲರ್, ಗ್ರಾಫಿನ್ ಮೀನ್ಸ್ ಟು ರೈಟ್. ನೆಕ್ಸ್ಟ್, ವಾಟ್ ಇಸ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಕ್ರೊಮಟೋಗ್ರಫಿ? ಯಾವುದು ಏನು ಪ್ರಿನ್ಸಿಪಲ್ ಅಂದರೆ, ಇನ್ ಕ್ರೊಮಟೋಗ್ರಫಿ ದ ಮಿಕ್ಸ್ಚರ್ ಇಸ್ ಸಪರೇಟೆಡ್ ಇಂಟು ಇಂಡಿವಿಜುವಲ್ ಕಾಂಪೋನೆಂಟ್ಸ್ based on their relative affinity towards both station and mobile phase during travel. The difference in the affinity arises due to the relative adsorption or partition coefficient in between the components towards both station and mobile phase. ಏನು ಪ್ರಿನ್ಸಿಪಲ್ ಅಂದರೆ, ಒಂದೊಂದು ಕಾಂಪೌಂಡ್ ಒಂದೊಂದು ಅಫಿನಿಟಿ ಇರುತ್ತೆ ಟುವರ್ಡ್ಸ್ ಬೋತ್ ಸ್ಟೇಷನ್ ಅಂಡ್ ಮೊಬೈಲ್ ಫೇಸ್. Affinity that is due to adsorption or partition coefficient. Okay, mixture is separated into individual components based on their relative affinity. Compounds do relative affinity towards both stationary and mobile phase during their travel. ಏನು ಅಫಿನಿಟಿ ಯಾಕೆ ಬರುತ್ತೆ ಅಂದರೆ ದಿಸ್ ಇಸ್ ಡ್ಯೂ ಟು ರಿಲೇಟಿವ್ ಅಬ್ಸಾರ್ಪ್ಷನ್. Affinity is due to relative adsorption or partition coefficient in between the components towards both stationary and mobile phase. Examples for stationary phase. ಏನು ಎಕ್ಸಾಂಪಲ್ಸ್ ಸ್ಟೇಷನರಿ ಫೇಸ್ಗೆ ಕ್ಯಾಲ್ಸಿಯಂ ಕಾರ್ಬೋನೇಟು, ಸಿಲಿಕಾ ಜೆಲ್ಲು, ಸ್ಯಾಂಡು ಎಕ್ಸೆಟ್ರಾ ಅದೆಲ್ಲ ಏನದು ಸ್ಟೇಷನರಿ ಫೇಸ್. ಮೊಬೈಲ್ ಫೇಸ್ಗೆ ಯಾವ್ದು ಮೂವ್ ಆಗುತ್ತೆ ಅದೆಲ್ಲ ಅದಕ್ಕೆ ಯಾವ್ದು ಎಕ್ಸಾಂಪಲು ಎಕ್ಸೇನು, ಕಾರ್ಬನ್ ಟೆಟ್ರಾಕ್ಲೋರೈಡು, ಅಸಿಟೋನು, ಪೆಟ್ರೋಲಿಯಂ ಇದ್ದರು ಅದೆಲ್ಲ ಏನದು ಮೊಬೈಲ್ ಫೇಸ್. ಓಕೆ, next classification. The first one is paper chromatography. It's a type of chromatography technique in which the mixture is separated into individual components by the application of high quality paper as a adsorbent. Paper chromatography ಇದು ಒಂದು chromatography technique. ಇಲ್ಲೇನು ಮಾಡ್ತೀವಿ, ಮಿಕ್ಸ್ಚರ್ ಇಸ್ ಸಪರೇಟೆಡ್ ಇಂಟು ಇಂಡಿವಿಜುವಲ್ ಕಾಂಪೊನೆಂಟ್ಸ್ ಬೈ ದಿ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ಹೈ ಕ್ವಾಲಿಟಿ ಪೇಪರ್ ಆಸ್ ಅನ್ adsorbent. In this case we are using high quality paper as an adsorbent. Main principle ಏನು, the basic principle of the paper chromatography is the continuous differential partitioning of components of a mixture between the station phase and mobile phase. ಅಂದರೆ ಇಲ್ಲಿ ಏನು ಪ್ರಿನ್ಸಿಪಲ್, partition coefficient of the components in the mixture between the station phase and the mobile phase. High quality paper ಅಲ್ಲಿ ಏನಿರುತ್ತೆ, it contains water ಇರುತ್ತೆ, water will act as a stationary phase. In paper chromatography, which one is stationary phase? High quality paper that contains water, it will act as a stationary phase. Okay, the main principle is partition coefficient. The basic principle of paper chromatography is the continuous differential partitioning of the components of a mixture between the stationary phase and the mobile phase. Okay, next theory. ಏನು ಕಾನ್ಸೆಪ್ಟ್ ಇಲ್ಲಿ, ಇನ್ ಪೇಪರ್ chromatography the stationary phase is a special quality paper called chromatography paper. The mobile phase is a solvent or a mixture of solvents. A solution of the mixture is spotted on a line about 2 cm above from the bottom of the paper called original line or baseline, then suspended in a chromatography chamber containing suitable solvent. The solvent rises up paper by capillary action and flows over the spot. The paper selectively retains different components according to their differing partition in the two phases. The paper strip so developed is called chromatogram. The spots of the separated colored compounds are visible at different heights from the position of the initial spot on the chromatogram. The spots of the separated colorless compounds may be observed either under ultraviolet light or by use of an appropriate spray reagent. ಅಂದ್ರೆ ಏನರ್ಥ, in this case in paper chromatography first we are taking high quality paper. This paper contains water. This water will act as a stationary phase. ಈ ಪೇಪರ್ ಏನಿರುತ್ತೆ ವಾಟರ್ ಇರುತ್ತೆ, this will act as a stationary phase. Then ಏನು ಮಾಡ್ತೀವಿ, at 2 cm from the bottom of the paper ಲೈನ್ ಡ್ರಾ ಮಾಡ್ತೀವಿ by using sharp pencil. ಓಕೆ, ಲೈನ್ ಡ್ರಾ ಮಾಡ್ತೀವಿ. ನೆಕ್ಸ್ಟ್ ನಮ್ಮ ಸ್ಯಾಂಪಲ್ನ ಸ್ಪಾಟ್ ಮಾಡ್ತೀವಿ ಇಲ್ಲಿ at baseline. Then we will place this paper in the beaker. This beaker contains solvent. This beaker contains mobile phase, petroleum ether, carbon tetrachloride, etc. ಅದನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, beaker contains mobile phase. ಓಕೆ, ಏನು ಮಾಡ್ತೀವಿ, ಈ ಪೇಪರ್ನ ಅದರಲ್ಲಿ ಡಿಪ್ ಮಾಡ್ತೀವಿ. Then this solvent undergoes interaction with this sample. Due to capillary action, it will move on the surface of the paper. Solvent undergoes interaction with this sample at particular time ಏನಾಗುತ್ತೆ, ಸಪ್ರೇಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ. The sample contains two compounds, that is A and B. Sample contains two compounds A and B ತರ ಸಪ್ರೇಟ್ ಆಗುತ್ತೆ. ಓಕೆ, after certain time. ಈ ಸ್ಪಾಟ್ ಏನಾದರೂ ಕಲರ್ಲೆಸ್ ಇದ್ರೆ by using UV chamber or some ಸ್ಪೆರೆ ರಿಯೇಜೆಂಟ್ ಹಾಕ್ಬಿಟ್ಟು ಅದನ್ನ ಸ್ಪಾಟ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಬೋದು. ಕಲರ್ ಕಾಂಪೌಂಡ್ಸ್ ಇದ್ರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕಾಣಿಸುತ್ತೆ ನಮಗೆ ಯಾವುದು ಸ್ಪಾಟ್ಸ್. ಓಕೆ, ಫಸ್ಟ್ ಏನು ಮಾಡ್ತೀವಿ, ವಿ ಆರ್ ಟೇಕಿಂಗ್ ಹೈ ಕ್ವಾಲಿಟಿ ಪೇಪರ್. ಲೈನ್ ಡ್ರಾ ಮಾಡ್ತೀವಿ at 2 centimeter from the bottom of the paper. then sample ನ spot ಮಾಡ್ತೀವಿ. okay, sample ನ spot ಮಾಡ್ತೀವಿ. then we place this paper in the beaker. This beaker contains solvent. This solvent will act as a mold phase. then this solvent undergoes interaction with sample. After a certain time ತರ spot ಬೇರೆ ಬೇರೆ ಸ್ಪಾಟ್ ಅಪೇರ್ ಆಗುತ್ತೆ ಆನ್ ದಿ ಪೇಪರ್. ಬೇರೆ ಬೇರೆ ಸ್ಪಾಟ್ ಅಂದರೆ ಬೇರೆ ಬೇರೆ ಕಾಂಪೌಂಡ್ಸ್. ದಿ ಸ್ಯಾಂಪಲ್ ಕಂಟೈನ್ಸ್ two compounds, that is A and B. okay, by using UV chamber or iodine chamber we can see these spots. okay, thank you.